Okay, so we're dealing with efficiency here. We have a voltage source, and so we could draw it like that or like a battery, whichever you wish. And then we have some transmission lines, and that's bringing us to our load. In this case, we could say load is just generally our city that we're serving, and back to ground or neutral, whichever way we look at it. And our transmission lines, we're told, have a resistance of 10 ohms. Our voltage source is 25,000 watts and 500 volts. Okay, so we have everything to get going here. So first of all, when we're talking about power and transmitting that power, we often pull out the equation P equals VI. And here, probably a good starting point is to figure out what is the current that's running through here. So I equals P over V. And we're talking about 25,000 watts all over 500 volts. And you can figure that out, pull out the calculator if you wish. 50 amps. So lots of amperage there going. And so from there, in order to figure out efficiency, we're going to have to figure out how much power is lost in those transmission lines. So in other words, in order to know how much the power the city got, we have to know what was provided minus what was lost. So the power loss and our equation for the loss of power, particularly over transmission lines, I squared R will work great. So we have 50 amps, and that's squared. And again, our resistance 10 ohms. And so 50 squared times 10, we come up with 25,000 watts. So what does that tell us? Well, our power in, or the power source, 25,000 watts. Power loss is 25,000 watts. So this isn't looking too useful here, because the power for our load or for our city, we could say is the power in, or the power source, minus the power loss. And that's 25,000 times 25,000, or 0 watts. And so, yeah, we are not looking at very good efficiency here. So this design was not thought out very well. To finish off, just to kind of proof of concept on where we know this is going, the efficiency isn't looking very good. In fact, 0. We can say the useful power, 0, over the power in, which was 25,000, and then times our 100 to turn it into a percent. And of course, that comes out to be 0%. So efficiency, 0%. Okay, not well designed.